Thank you very much. Okay, so yeah, my name is Alison Monaghan. I'm from the British Geological Survey, and I'm going to talk to you today about a geological observatory for mine water heat and heat storage in Glasgow. So essentially this is some infrastructure and a lot of open data that goes with that infrastructure. So I wanted first just to pause a little bit about some of the questions that people have described during this meeting, some of the risks of drilling into mines, and think about why we need an underground laboratory looking at mine water heat and heat storage. We've seen some excellent talks today and yesterday about demonstrator schemes and commercial schemes, and about the economic case, about the markets that need to develop around mine water energy. And that is very much something that needs to happen. But there's also a space for an at-scale observatory where people can come along and essentially do things flexibly. They can take heat in, so take it out, put heat in. They can do it on different timescales. They can stop, they can start, and so on. So an observatory is a place that's flexible, but is at scale, and it is somewhere where lots and lots of sensing and measurements and monitoring can go on to greatly increase the evidence base around mine water heat and heat storage. It's also a place where there's a lot of environmental data can be collected and a space for innovating technology. So essentially an observatory is a place where you can de-risk some of the aspects that have been talked about in the meeting over the last 2 days using research. So some of the questions that have been talked about are around the uncertainty of drilling into the subsurface and the cost and risk that that creates. So the observatory that's in Glasgow has been designed to try and address some of those uncertainties. It's a place where there's a lot of monitoring and sensing equipment and so on. So essentially, when people come to drill boreholes into a mine system, so this image here is an open cast site with some old stoop and room workings in it. Clearly, if you drill a borehole in this location, you're going to have a very different outcome in terms of your hydraulic properties and so on if this was deep underground and filled with water, than if you drill the borehole here into the intact coal seam over scales of a few meters. So really understanding that kind of risk and optimizing borehole drilling and design and what we do when we have those boreholes is really, really important to the economic case of mine water schemes. So the observatory in Glasgow will hopefully allow people to look at things like the yield you get in different types of mine working. So that's not just in void, but as we saw in a previous talk where there's backfill into the mines, or there's collapsed mine workings, to look at the recharge and heat processes. So Charlotte described, what happens to the heat when it's in the mines. How does it move? How does it get dispersed? That's really important, and we need to understand those processes better. What happens under cycles of heat within the mines? If we do it many times, how does that affect the mines and the chemistry and the geomechanics and so on? And one question that I think has really come out for me of this meeting today is about heat abstraction or heat storage. And there's been several presentations about heating and cooling, and potentially they're two ends of the same thing, but they actually require different things. So for heat abstraction, obviously we're taking out. For heat storage, we want to contain the heat. And so maybe when we're looking at the risk of drilling boreholes, for example, we look at those things in a different way, that if something isn't suitable for heat abstraction, then maybe it's suitable for heat storage, especially when we're drilling into different types of mine working. So the Glasgow Observatory is a place where all those kinds of ideas can be explored and data can be gathered to evidence them. So in itself, the Glasgow Observatory is some infrastructure, it's some boreholes with monitoring equipment where people can get samples and share open data. But then that means that we can study things like the sustainability of the resource, the environmental impacts associated with the resource, and so on. And then thinking more widely, that will then flow out into things like regulation and policy. So if we look in a bit more detail at the observatory in Glasgow, Glasgow is in Scotland, for those of you not familiar, and it's the location of the COP26 summit later this year. So the observatory in Glasgow is in an urban area. It's an area of urban regeneration. It's typical of many coalfields across the UK. So on this air photo, here's the city centre of Glasgow. And we're in the east end of Glasgow in an area of urban regeneration. This area here is part of the Commonwealth Games Village that was built in 2014. And the area where most of the boreholes are for the observatory is under this loop called Cunningar Loop around a meander of the River Clyde. And underneath this area are 7 worked coal seams from a colliery that was in approximately this location from the 1830s to 1920s. The colliery was active. So our boreholes, we've got 12 boreholes, and 6 of them were targeting mine water. 6 of them are mine water boreholes that targeted coal seams, and they're arranged in a triangle, and they're at 2 different depths. One at a coal seam that's about 50 metres down, and one that's about 85 metres down. And then next to those, we have boreholes that are environmental baseline monitoring boreholes that are shallower, but take the environmental baseline and are there to see if there are any impacts when we start pumping the mine water boreholes. There is also a deeper borehole over in Dalmarnock where it's approximately 200 metres deep, and this was a cord reference section came from this borehole, and currently the borehole is a seismic monitoring borehole, which adds to the UK National Seismic Monitoring Network. So the observatory, as you can see, is a number of boreholes, but it's a lot more than that. So we've got boreholes in research compounds, and down those boreholes are a lot of sensor cables. So there are electrical resistivity tomography cables, and there are fibre optic cables for direct temperature sensing, and there are obviously hydrogeological data loggers down the boreholes, and the boreholes are there for groundwater monitoring. The observatory developed through a lot of stakeholder engagement, and as we had to go through the same regulatory process as any other mine water scheme, through all those steps, there was an amount of public engagement with the local community as well to secure various permissions. One thing about the observatory is that there is a large environmental baseline monitoring programme of the environment. As it's a very complicated environment due to the industrial legacy, it's really important that we record what was there before we start doing any drilling operations and any pumping operations. So there's been a comprehensive suite of water, gas, soil, and so on monitoring at the observatory. And finally, one of the key aspects of the observatory is that the data is openly available, and it's available on the website in a number of data packs, and coming in the near future will be some continuous and time series data coming from the observatory. So that open data is really important, both from the scientific research base, but also in terms of awareness of the observatory and social acceptance to see that information is not being hidden. So just to very briefly talk a little bit about the boreholes. Here are 2 cross-sections of the geology that the boreholes penetrate into. So these are 4 of the mine water boreholes. So they're in pairs going into the mine water, into the mined coal seams. So this is the Glasgow upper coal seam, which has got quite a few pillar and stall or steep and ream mine workings. And then the deeper boreholes go through the Glasgow L mine working and into the Glasgow main mine working. And as I mentioned, the boreholes have got sensor cables down the outside and the annulus. They are screened at the target interval, which is the mine working, and they've got hydrogeological data loggers within them. And what's important also is that the boreholes target different types of mine working. So in some cases, we've got the fractured rock mass. In other boreholes, we've got mine waste or stowage. And in other cases, we've got voids. So all of those different types of mine working give different hydrogeological properties and different scientific opportunities to study their behaviour. So looking at an optical camera image from down one of the boreholes, just to give a flavour of the different types of mine working that have been encountered. This image on the left-hand side is going through the Glasgow upper coal seam. So this was an intact coal pillar that was penetrated in this borehole. It was slightly disrupted at the base. Going down through the same borehole on this image, what we've got here is a packed waste of the Glasgow L mine working, so a cemented mudstone breccia essentially. And then our target in this borehole was the Glasgow main mine working, which is this black void beneath a sandstone roof and a disrupted floor. And as mentioned before, across the boreholes, there are different mine workings like this penetrated, and that gives a different range of hydraulic properties. So different opportunities for looking at how heat disperses within the mine working system with different research implications and resource implications. So just a little bit about the hydrogeological test pumping to appraise the mine water resource at the observatory. We've just undertaken some very initial test pumping, and in the future we hope that people will come and undertake their own research at the observatory. But here's a couple of photographs of that very initial test pumping and the water sampling and monitoring that was done. The water in the mines system is around 12 degrees C, and it's actually very good quality for mine water. And there was very variable yields from the different types of borehole. So these graphs show some results from one of the mine water boreholes, GGA01. So the graphs are of a hydrogeological step test and a constant rate test. And for this borehole GGA1, this was a mine working borehole that goes into the top coal seam, where that coal seam was a waste, a stowage, probably a backfill into that borehole. So you can see very nicely the effect of the step test on the water level. So these are from the hydrogeological data loggers. The water levels as that borehole was pumped up to 25 litres a second. And similarly with the constant rate test, up to 20 litres a second for 5 hours. But what's important for the science outcomes of people using the observatory in the future is how the other boreholes respond. So these data logger responses up here, those are the responses in adjacent mine working boreholes and in the bedrock, which is above the mine working. So you can see there is connectivity between those mine workings over hundreds of metre scale and into the bedrock. And then the green line up here is the deeper mine working. And you can see that there isn't a response to pumping the upper borehole within that deeper mine working. So this is very initial hydrogeology, but it helps us to really understand the conceptual hydrogeological model of the whole system as a basis for future research. And this data will shortly be coming out as a data release on the website. Just one slide on the environmental baseline surveys mentioned before, with a few pictures of my colleagues doing that work. So yeah, there's been soil chemistry surveys. We've done gas surveys before and during drilling, looked at the surface water chemistry and the groundwater chemistry. There's also been work done on ground motion studies using INSAR remote sense data, and we've got our seismic monitoring borehole. So thinking back to the discussions yesterday about environmental impacts and regulation, there is a lot of data that has been started to be collected from before the observatory was developed and will continue to be collected, that will be very important for constraining the environmental impact side. So using the observatory is a NERC and UKRI research infrastructure, and it's there for both academic and commercial research and development and innovation for people to come and use. And we very much hope people will do that. This is a picture of one of the research compounds in the summer last year. We have been delayed putting some of the monitoring equipment on site because of COVID restrictions. In this photograph, you can see, if you look very carefully, you can see the manhole covers, which have got 3 of the boreholes beneath them. And then there's cabinets that contain the electrical connections and the data loggers for the cables that go down the boreholes. And then there are plinths there for monitoring equipment that is to be installed. So the ground motion sensing equipment, the near surface gas scanning lasers, and so on. And we also have planning permission and environmental permissions now to install a permanent geothermal infrastructure. So in this compound, for example, there will be a small heat centre going in, and there will be mine water pipe between some of the boreholes to enable heat and flow experimentation within the research facility. So I've just got a set of 4 slides just to give a flavour of how the research observatory may be used by people who want to look at de-risking aspects of mine water heat and heat storage. So in this first example, say you're interested in characterising a subsurface resource, then the boreholes are there for, say, you to come and do a pumping experiment and look at the response of that pumping in adjacent boreholes, either through depth or across the observatory in a few hundred metres away in other boreholes. And that might be answer science questions around rock and fluid processes at different scales, and look at heat distribution and heat profiles, look at the connectivity within the mine systems, and so on. There's also the infrastructure there to look at the environmental management of mine water schemes. So the environmental impacts, the interactions potentially of the subsurface to the surface. So an example here on this image is if you use the fibre optic cable. So there are special fibre optic cables in the boreholes which are heatable. So these could be heated to look at the thermal response of the rock mass surrounding the boreholes, or you could inject some warmer water, as we saw in a previous talk, and then look at how that disperses within the rock mass and within the mine workings. But you could also monitor what's happening in surrounding boreholes within the rock mass and also at the surface using the surface monitoring infrastructure. So looking at the environmental impacts. Another area where we hope people will use the observatory is for innovation, to come and test new tools and techniques, and it has the flexibility to do that at scale. So there's a couple of examples there on problems that we've seen, such as clogging, maybe testing out new sensors, or looking at all the data that's coming back and optimizing that for future schemes. And then finally, a final example, once our infrastructure is in place for abstraction and reinjection of the mine water, and there will be a heat pump chiller for either adding or taking away heat, then there's a lot of research that can be done around subsurface change and the sustainability of the resource, things like thermal breakthrough, the extent of the system, the footprint of the system. So this image here is just an illustration of some of the preliminary results from the downhole temperature sensor in the DTS fibre optic cables. So those are pieces of kit where time series data will come out, and that will enable essentially 4D monitoring of the subsurface to happen at the same time as pumping the system and taking heat in and taking heat out. So many scientific and research questions hopefully will be able to be evidenced through those kind of techniques. So we very much hope people will come and use the open data and use the observatory. And I put the web address here. Just to note, there is currently a call for groundwater samples live if people would like to start doing some work using water from the observatory. And also in the next few weeks, there will be a tender going out for the detailed design and build contract for the geothermal infrastructure at the observatory. So just to summarise and finish up, the Glasgow Observatory is some infrastructure for mine water heat and heat storage. And there's a lot of open data already available, and that will grow through time. And that is a space where people can come and we can greatly increase the evidence base on some of these risks and questions that people have described in previous talks. So, for example, how to transfer heat sustainably and economically. And the observatory is a place where that can be done at scale and through time in a lot of detail. There's also the opportunity to look at the environmental management of mine water heat and heat storage using all the various techniques and technologies. And there's space there to test out new technologies. So hopefully all of that gives a slightly different opportunity for people to come and look at mine water heat and heat storage towards decarbonisation of heat. Thank you very much.